So we talked before about position. So we have an object, it's at some position x. Okay, there's my origin, and it moves. So it's going to be in some other x at different times. And so we had realized that velocity, average velocity, was change in position over time. Okay, the instantaneous velocity dx dt. Okay. So again, this is what I just said. And so the average velocity, we define that as the displacement. Remember, delta x is displacement over time. The displacement is the x at some later time minus the x at the original time. And so we take the limit, and that gives us the derivative, which is the velocity. Well, acceleration is basically the same basic concept. It's the rate of change of velocity. So acceleration, change in velocity over change in time. Well, the change in velocity is going to be the velocity. So you imagine the thing. Up here we got the origin, and here's an object here at some position x. It's moving that way. So let's say it's got a positive velocity. So at some later time, it's somewhere else with a different velocity, perhaps. And so at the initial time, there's the velocity at a later time. This is how much later. So we take the limit as delta t goes to 0. Again, we have a derivative right there, and that gives us the instantaneous velocity right there. Okay, now, as with velocity, you remember when we were talking about velocity, okay, when we talked about velocity, we said that if we have the origin here, if it's moving that way, that's positive velocity. If it's moving that way, it's negative velocity. On the other hand, if the origin's this way, okay, if I say this way is positive, in other words, if I call this, 0, 1, 2, 3, 4, that direction's positive, so a velocity in that direction is positive, velocity in that direction is negative. It doesn't really matter how you position it. Okay, so velocity, the direction of the velocity, positive velocity means you are going in the direction that is positive. Okay, so negative velocity means you're going in the other direction. And so acceleration, it pretty much works the same way. If you're got the origin here, if you say that direction is positive, then an acceleration in that direction is positive, and acceleration in that direction is negative. What does this mean? Well, it means that if you're moving this way and go faster and faster and faster, okay, if that way is positive, you're getting more and more velocity. So that means the velocity later is bigger than the initial velocity. So you've got positive acceleration. So you're going faster. If you're going this way, you're slowing down. Then what happens is the final velocity is less the initial velocity. So velocity is negative. You're slowing down. Well, yeah, sort of. Okay, so suppose that I was right here, and I'm going this way, and I'm going faster and faster and faster in this direction. Well, going faster means positive acceleration, right? Well, no, because in this case, your final velocity is a bigger negative number than your initial velocity. Well, that means that the acceleration is negative. Means you're speeding up in the negative direction. So negative acceleration does not always mean slowing down. Negative acceleration could be speeding up in the negative direction. And in that case, a positive acceleration would be slowing down in the negative direction. And so you have to keep track of sign here. Well, there's another interesting concept. You don't always have constant acceleration. Acceleration can also change. And so if the acceleration changes, We got to have a name for that. So the change in acceleration over time is the jerk, the average jerk. Again, we take the derivative, and we would say that the derivative dA dt is jerk. Okay, so refreshing our memory. We have an object right here at some position x. Now, it might be moving. To find the motion, we have the velocity, and the velocity is dx dt. The acceleration would be the rate of change of the velocity. Well, notice that the velocity is dx dt, so that's going to be the derivative of dx dt. So that means it's the second derivative. Well, likewise, the jerk, which is dA dt, is going to be the second derivative of the velocity. And it's going to be the third derivative of position. Okay, so this is acceleration. So next, what we will be doing is we'll be doing an example of actually applying these things.